So we're gonna do modeling with functions. The main idea first, because is to write. Usually, you're gonna have two functions or two quantities, like volume and area, okay, or volume and surface area, and the idea is to write one in terms of the other, because you're gonna need this for optimization problems, which means to find the maximum or minimum, okay. So the best way to do something like this, let's start with like a box. So you have a box. So this is going to be the basis for the whole thing. So you have a box. Okay. Then it has three measurements: the length, the width, and the height. Okay. So those are the three quantities. Now, there is two formulas that you should remember from high school. If not, here they are. I highly recommend you to memorize this. And the formulas are: volume is length times width times height. And then the surface area, notice that this has 6 sides, 1, 2, 3, 4, 5, 6 sides, is 2LW plus 2LH plus 2WH, okay? So you should memorize these formulas. We're going to use it over and over, okay? So one is the volume and the other one is the surface area. So let's do this problem first. It says a breakfast cereal box has to have the following dimensions, okay? The box, the width has to be 3 times the length, okay? So this is the given information is right here. So given is that the width is equals to 3 times the length, and also that the height is equals to 5 times the length. Okay, so that's a given information. So the question is asking you to express the volume as a function of the length. What that means is when you get the volume formula, you should only have length at the other side. See, notice here, this is the formula we're going to use. Volume has three variables. So you have to rewrite this and this in terms of L. That's all it means. So when you finish the function, or when you finish the problem, it should only be a function of L. So what this means is, okay, the volume should be a function that depends on the length only. That's what that means, okay? All right, so then we start with this formula, the volume formula. Remember, volume is length times width times height. And then you're going to use this information, just plug it in. So length is length, but the width will be 3L, and then the height is 5L. So then if you multiply, 3 times 5 is going to be 15, and then L times L times L, it will give you L cubed. And now you can see here now that the volume is a function that depends only on the length, where the function is 15L cubed, and that's it. All right, so just try the number 2. Just use the same information. We'll go over like in 2-3 minutes. All right, so let's try this. So remember, this is asking you to write the surface area. So the first thing you should do is write the official formula for the surface area, which is this, and then plug in the information that they give you, okay? So you have 2L. They told you that W was equals to 3L, and then H was equals to 5L, and then you just do the same thing. Just replace W for 3L and H for 5L, and then just multiply. Okay, so then here, the first part is going to be 6L squared plus 10L squared plus 6 times 5 is 30, so it's 30L squared. So therefore, you have 6 plus 10 plus 30, this is 46L squared. That's it. So now again, you have the surface area. It's a function that depends only on the length. That's it. That's what they ask you. Okay. All right, so now part 3 is the one that gets people a little more confused. For part 3, you still want to, now you have these two formulas. Remember this one and this one, that they came from simplifying this, okay? But now it's asking you specifically, write the volume in terms of the surface area. So what that means is this, look, you have to find a function in terms of S, so that describes the volume, okay? To do this, what you have to do is the following. Notice that volume is equals to 15 LQ, and the surface area is 46 L squared. So both of them have L in common, okay? So since it's asking you to write the volume in terms of the surface area, well, volume, this is what you have so far. Volume is 15 L cubed. And what it's asking you to do is to change the L into S. But now from here, okay, so notice this. So if S is equals to 46 L squared, that means that L squared is equals to S over 46, which means that L is the square root of S over 46. Also from your previous math classes in high school, remember that this can be written as S over 46 to the 1/2. Okay? It's very important that you remember this, that the square root of X is the same thing as X to the 1/2. We're gonna talk about specifically that like in a couple of weeks, but for now you just need to remember that part, okay? So then, now here, you look at this, you have an equation for L in terms of S. So all you have to do is change L into this. So that's it, okay? So therefore, here we have, this is 15 L Q. And then depending on whatever the question is asking to simplify, you can either write this one or write that one. So let me do the two of them. So therefore this could be just the square root of S over 46, and this is the complete answer. Or the volume will be 15, then this will be S over 46. And then I told you that this is 1/2. 1/2 times 3, the 3 you have outside, is equals to 3/2. That comes from recall from the exponents that you did also before. You have like x squared to the 5th power. You multiply this times that. And this could be fractions too. So 2 times 5 is 10. That's how you get that. Okay, any questions on this? We're gonna deal with area and perimeter, so we're gonna go from 3 dimensions to 2 dimensions. And the idea here, we're gonna get a quadratic equation. You have a quadratic equation, then you find the maximum or minimum by just finding the vertex, okay? But before we get to the equation, this is the point of optimization. So optimization is gonna be to find the maximum you can get with the available resources, okay? So optimization is something like this. If your mom tells you, what do you need for school? And you say, for school, I need a laptop, a backpack, and books. And your mom tells you, okay, just buy whatever you want. There is no restriction there, right? So you don't have to worry about finding the best value, because your mom says spend whatever you want. Now, if your mom tells you, look, you need these 3 things, I'm only giving you $2,000 or $1,000, that's the constraint. So you cannot buy a laptop that is $5,000 and you only have $1,000, okay? So here, and this is gonna be the case for the previous example, if they give you the area, then the perimeter, if you want the area, then the perimeter is the constraint. If you want the perimeter, then the area will be the constraint, okay? So the two things are related. All right, so now here, just to see why we need this, let's say that you have 140 feet of fencing, and you're gonna create a rectangular garden, okay? And then it asks you to give 2 possible rectangles, and this is to show you why the shape or rectangle you make matters. For example, look, let's say you have Pedro here, and Pedro decides to do this. He said, I'm gonna put 10 in here, so therefore this will be 10. And since you have 140 total, then this will be 60, and this will be 60. So what is the total area for this? It's 600 feet square. Now, just to make it more tangible and more realistic, let's say that the purpose for doing the garden is you have boxes that are 1 feet by 1 feet, okay? And you want to put the boxes in there. So therefore, how many boxes can you put here if it is 600 feet square? Well, obviously it's 600, right? So you can put 600 boxes in there, and each box has one plant inside, okay? So now, let's say that Ramon decides to do this instead. He's like, okay, I'm gonna do this. Both of them have the same constraint. That's the whole point. The constraint, both of them, is they can only use 140 feet of fence. But let's say that Ramon decides to do this. I'm like, look, I'm gonna put 20 here, 20 there. So therefore, 50 has to go there, and 50 goes there. Now, how much is 20 times 50? Is 1,000. So therefore, at this point, which one is more efficient? The shape that Pedro did or the shape that Ramon did? Well, clearly it's what Ramon, okay? So now, this is technically some of the basis. If you're gonna study economics and business, you're gonna do this at the beginning. Because just think about this. Look, let's say that the fence will cost you $30,000 to buy the fence. Well, if you do this, you can put 400 more plants than this one. So therefore, from the business point of view, you don't want this one, you want this shape. So the question is gonna be, well, is there another dimensions that will give you the maximum area? And technically, you can just do trial and error, like try all the dimensions, and eventually you'll figure it out. So instead, we want to do this in general, so then you find the quadratic equation, and then figure out the vertex, and that should tell you what the answer is, okay? So if we do this in general, this is what we have. You will have a rectangle, and just like we did in the previous problems, this is going to be the length, and this is the width. That's what we know so far. And then there are two quantities here. The area, which is what you want. You want the maximum area. And then the other one is the perimeter. What is the formula for the perimeter? Is 2L plus 2W. Okay? Now, what is the given information you have? Or in this case, a constraint. What is the constraint to the problem? So therefore, the 104 is a constraint. So from here, the given information or the constraint is going to be the perimeter is 140. So therefore, you're going to have 140 equals to 2L plus 2W. Okay, so that's the constraint. So now, what you want to maximize is the area. Okay, the area is the length times width. Here's the problem. You have two variables, and you can only have one for this to work. So this is where we had to do what we did in the previous problems, and just write either this in terms of the width or in terms of the length. It doesn't matter which one, you just have to pick one. Sometimes one is easier than the other one. So here what I'm going to do, I'm going to solve for W. So if I solve for W, or the width, then what do we have? You have 2W, it will be 140 minus 2L. Is that okay? And therefore, you divide by 2, this will give you W is 70 minus L. So now you have the width in terms of the length. Okay? So then if you plug it in here in the formula, it will be the length times the width, which is 70 times the length. And now notice that now this is a function that depends only on the length. You only have one variable, so you should be able to solve the problem. If you distribute this is 70L minus L squared. And to make it easier, and you see why I'm gonna write like this is L squared minus 70L. I mean plus 70L. Which this is a quadratic equation, and based on what we did before, since the value for A is negative, that means that this is what is going down, which means it has a maximum value, and the maximum is going to be the vertex. So you have to find the vertex, which is what we have done a few times already, to find the vertex, okay? So therefore, the next part says, find the dimensions with the largest area. So it's asking you to find the vertex, okay? So we did this before, so you have the area is minus L squared plus 70L. So just write it in a standard form and find the vertex, okay? Just try that, and I'll go over this in 3 minutes. Okay, so let's check on this. So to complete the square, remember you need to factor out the minus sign first, because the number in front of L squared has to be positive. So this is minus, and then this will be L squared minus 70L. Okay. And then you divide minus 70 over 2. Again, this is not new. This is minus 35. And then what do you do with the minus 35? You square, so this is 1225, right? Anybody check? Okay, so therefore you add 1225 here. So what should be the value that goes here? Plus or minus? The one that will go here. It should be plus 1225. Why? Because you are technically subtracting minus 1225. So to cancel, it has to be positive. Remember, this is negative, this is positive, this is positive, this is negative. Then if you complete the square, this will be L minus 35. Why 35? Because that's the value you got with y by 2. And then plus 1225. So therefore the vertex is 35. And the maximum area is 1225. So then, what is the maximum area? It will be 1225, and that happens when x is 35. Sorry, the length is 35. So when the length is 35. Okay, so that's telling you what the area should be. So now, if you do a rectangle now, so this is very important, so you should remember this for the rest of your life. So here it is. If the length is 35, well, that means this one has to be 35, and therefore this one has to be 35. So what is this shape called when all the sides are the same? It's square. So therefore the square is always going to have the maximum area of all rectangles. So remember, all the squares are rectangles, but a rectangle is not necessarily a square. So if I ask you what's the best choice for all rectangles, it's always going to be a square. Okay. There is only one shape that has more area than a rectangle. What do you think that is? It's something that you see every day, literally. What's the shape of a pizza? It's round, right? So now, but what do you think for a garden? What do you think a circular shape would not be a good idea? Because remember, in this case, you're putting boxes, right? The boxes are square. So because of the corners, this is not going to be a good idea. But if you want area itself, like a pizza, then this shape will be better than this shape. Okay. By the way, what we did here, you don't have to do the graph, but you did the graph, which we're gonna do other graphs similar in a little bit. You do the graph is gonna look something like this. Look, you have 0 here. This is 35. 35 is here, and then 70 it will be here, and this is the maximum area, the 1225. So if x, so this is the length, if this one was like 10, then this will be like 600. So this is telling you that, okay, you start technically with no area, and I'll ask you that in a second. Then it keeps increasing. It gets to the maximum value, and then it keeps decreasing until it gets to 0. So the maximum you will ever get is you have a square. Let me check your high school years again. So if you have a can, what is the volume and surface area for a can? And remember the formulas. Anybody remembers those from your high school years? So you have a can, you have technically the base is a circle, and then on the top is a circle again, right? So you have a radius, and you have a height. Okay. You forgot the formulas, not a big deal. You remember, just tell me. What is the volume? Anybody remember for the volume? If not, it's fine. What is the area for the bottom is a circle, right? What's the formula for the area of a circle? It was pi r squared. So that's just the circle. The height is the other missing part, so therefore this is the volume for a cylinder. And the surface area, notice that you have a top, you have a bottom, so you have 2 pi r squared. So that's the top, the bottom. And then on the side, if you look at a piece of paper, look. You have a piece of paper and you fold it, what do you get? You get a cylinder. So the surface area is this, which is technically a rectangle, okay? This is the circumference, which is the perimeter, and this is the height. So therefore the formula is plus 2 pi r h. So these are the two formulas that we're gonna need. Okay? You don't have to memorize it, I can just give it to you right now. It says, manufacturer makes a metal can that holds 100 liters of oil. So find a function that models the surface area in terms of the radius. So what this is asking you to find is find a function where the surface area is a function that depends only on the radius. Okay? Now notice here, the surface area depends on the radius here, only is fine, but this one depends on the height. So you need to get rid of the height somehow, okay? So what is the given information? The given information is that the volume is equals to what? 100 liters, right? I'm just gonna go with 100, so that's the volume. But what is the formula for the volume? It's right there. What's the formula for the volume? Pi r squared h, okay? So therefore from here, you have 100 is equals to pi r squared h. Now, how do we solve for the height only? What do we do? What do you have to divide both sides by? You want to leave h by itself. What do you divide by? Pi r squared, right? So therefore this will be 100 over pi r squared. And that's now h in terms of r. So then if you go back to the formula, the surface area is 2 pi r squared. And then instead of h, which is this one, okay, so h, this is what we have. Then you're gonna plug it in here. So you're gonna have h, and you're gonna plug that in here. So the h will go here. Then you just have to simplify. Okay? So if we do that, you leave this alone. So this is h, which is 100 over pi r squared. Now, what can you simplify from here? There's two things that you can cancel. You can cancel the pi, and what else? One of the r's. Okay, remember you have r over r squared. This is the same thing as r over r times r. This cancel 1, so this is 1 over r. Okay? So and if you multiply, then the surface area will be 2 pi r squared. How much is 2 times 100? Was 200 over r. So So all of this, when you simplify all of this, you end up with this part. And now you have the surface area in terms of just the radius. Notice there's only one variable there. Okay, so this is the algebra part. If you were taking calculus, they will ask you to do exactly this thing. And then from here, there is like 4 or 5 more steps you have to do using calculus. But if you can get here, there's no way you can do the calculus part. So that's why, again, the calculus questions depend at least 80% just doing algebra. Okay? So for number 2, this is very similar to the first example we actually did. Okay? So remember, you have a box. The volume, the formula for the volume is length, width, and height. And the surface area is 2LW plus 2LH plus 2WH. So these are the formulas that you're going to need. Now, keep in mind that the problem says you have a square base. You need to figure out what that means. And it says find the surface area in terms of the volume. That's a typo. This should be in terms of its length. Okay? When the volume is 80 feet. So that's a typo. You just cross out the volume part there and just try this. So the point is you need to have the surface area when you finish. The surface area has to be a function that depends on the length only. Okay, so just try that for 5 minutes and I'll check it right now. Let's check. Okay, so first, you know that you have to use these formulas because it has to do with the box. Okay, so this is the volume, the surface area. So these are the formulas you have to use. And then what is the given information? Okay, remember in the previous problems we did before, they will tell you the length is 3 times the width and the height is 5 times the width or something like that. Okay, this is very similar. It's not the same, but it's telling you that it has a square base. So what does a square base means? So what does a square base means? The length is equal to the width. So that eliminates one variable right away. Okay. So therefore, from here, look, if we use that, then the surface area, if we use the square thing in here, then the surface area is going to be L squared. I mean 2L squared. 2L squared. Let me write that nicely. So it should be 2L squared. How do I get L squared? Well, if the length and the width are the same, L times L is L squared, right? So since that's what a square means, so L times L should be L squared. So that's 2L squared. Is that okay? You don't look pretty convinced with that? No, okay. Okay. So then, since the length and the width are the same, then this should be 2LH, because L is still L. But notice this one is the same thing as L also, right? So that will give you 2LH only, and that will come from here. So this give you this. So now notice that you can combine these two, and if you simplify, this should be 2L squared plus 4LH. Okay, and we're almost there. The only issue now is that you have a H and you can have H in here. So how do we deal with that? Well, we come to the volume formula. And over in the volume, since the length and the width are the same, and the volume is 80, because they also give us that, the volume is 80. So that's another of the given information, that the volume is 80. So you can say, well, the volume should be L times W. Since L and W are the same, this should give you L squared times H. Okay? So from here, you can solve for H. This will be 80 over L squared. So then you plug it in here, and then you simplify, and you'll be done. So therefore, this is 2L squared plus 4L, and then H is going to be 80 over L squared. So now notice that you can cancel this with this, and also notice the similarity between like this problem the answer to this one and the answer to this one. Notice it's exactly the same, except that this is for a circle and this will be for a box or a square. Okay? So you simplify fully, you have the surface area is equals to 2L squared, which is the same thing as the area of the box, and here this is the area of the circle. You have 2 then, and then the next one is going to be plus how much is 4 times 80 is 320, and then divided by L. So again, look, just check the similarity between this and this. Obviously this is the final answer for that. The next problem here is also another problem that you will see in calculus. We cannot solve the problem here, at least not completely, but what you can do is set it up. And this is a lot easier than what it looks, okay? This is a classic problem from calculus, and technically it tells you the following. Look, you will have a wire, or it could be anything else, but let's say a wire, something you can cut. And the distance between here and here is going to be 40 centimeters. It could be anything. You can also do this in general, just by calling it the length or something, okay? And then you're going to cut this somewhere, and you don't know where, so just anything. And whatever you cut, you're going to call it X, okay? And this part, I'm going to call this green part, and then the blue part. With the green part, you're going to do a square, and with the blue part, you're going to do a circle. Okay, so how can we do that just based on that information? All right, so just create 2 equations, one for the square, one for the circle. I'll give you like 3 minutes and then I'll show you. It's a lot easier than what it looks, but you need to go through the process of suffering for a little bit to see it. Okay, so just try and I'll show you in 3 minutes. All right, so this is how you deal with this problem. It's a lot easier than what it looks. Look, if the green part is X, so from here to here is X. What is the whole thing is 40, okay? But let's say that this one was 15. If this was 15, what should this be? That's a really good question. If from here to here was 15, how much is this? It's 25, right? So it should be obvious. How do you find 25? If this is 15, how do you find 25? It's 40 minus 15, okay? So therefore, essentially, from here to here, the length is X, and this one is 40 minus X, right? Because how much is, X plus 40 minus X is exactly what? 40, that's what you have, okay? So then, since you're gonna use this to make a square, what is one of the qualities of the square? All the sides are the same, right? So if you have X amount of material to make a square, well, that means that for the square, the area, it has to be X over 4 square. Why? Because you have X to do the whole square, so you have to divide it in 4 pieces. So therefore, this should be X over 4, X over 4, X over 4, X over 4. Because if you add it, you'll end up with X. Now, what is the area for the circle? The area for the circle is what? Is the area is pi r squared, right? But what is the thing you are missing here, though? You have the pi, you need the r squared. How are you going to figure out the r? Well, what's another formula for the circle? The circumference is what? 2 pi r. And what is the circumference for this thing? Is whatever is left. You're going to need all of this to make the circle, okay? So therefore, from here, that means you have 40 minus x equals to 2 pi r. And if you solve for r, it's going to be 40 minus x over 2 pi. So then you plug it in here. This is the formula for the area of the square, and the circle if you cut the y or whatever x is. Now this one, if you actually see you are really bored, and I mean like really bored in your house, okay? This is a quadratic equation, so therefore you should be able to find what the vertex. It's not going to be fine at all. Why? Because it has the fractions, but it should tell you exactly where you should cut it so you have the maximum area. Okay? But for now, all you have to do is write it like this. Now you can simplify this a little bit more if you want to. Like this one becomes x squared over 16. Here, notice that if you square this will be 4, and this will be pi squared. So therefore, you do that, that will cancel one of the pi's, and this on the top still will be 40 minus x squared. And then on the bottom, this should be 4 pi. I mean, you don't have to go that far. If you get this far, this is good enough. All right, so now let's do some problems that we have done before. So this is kind of a review, but emphasizing that these are optimization problems. So we have solved these problems before. You even have those on the first test. So I actually even did this exact same problem before. So here, the problem says the height of a missile, or the illustration says, given the height of a missile is given by this, find the maximum height. If I give you the graph, it's obvious that the maximum height happens when x equals to 2. Now it's not obvious what this value is, but it is 144. Just check your notes. We did that before. Remember that this is technically a physics problem where this is related to gravity. This is the initial velocity, and this is the initial height. Okay. Now, how do we figure out the 44? Is by completing the square. So just checking out from before, but once you complete the square, I'm going to do that in the next problem. You end up with minus 16 times t minus 2 squared plus 144. So you should check this. So check by completing the square. Okay, we did this exact same problem before, but now I'm going to do a new one. It says the height of a missile is given by the following function. Find the maximum height that the missile reaches. Okay, so first thing we had to do is put this in a standard form, and it's the same method we did a few times already. So you factor the 16, so this should be t squared minus 8t. So we need to complete the square. So to complete the square, remember you divide this number by 2. So minus 8 divided by 2 is negative 4. And then you square that value, so negative 4 squared is 16. So you add 16 here, but notice you don't add 16. You are adding minus 16 times minus 16, which is minus 256. And to get rid of minus 256, well, you add 256. So this should be plus 256. So then if you write it in standard form, this will be t minus 4 squared plus 256. Notice that the vertex is 4, 256, which means it takes 4 seconds to get to the maximum altitude, and therefore the maximum altitude will be h of 4, which is 256 feet. If you were going to do the graph, look like this. This is 4. You should check that it will take 8 seconds to hit the ground, and this is the maximum 256. All right, let's do one last example in which finding the vertex will give you solution to the optimization. Remember, optimization means best answer given the constraints. All right, in this example, they give you a quadratic equation that tells you the miles per gallon that you will get given the speed. So M is going to be the miles per gallon, and S is how fast it's going. Notice that this is negative, so therefore the quadratic equation or the graph is going down, the parabola is going down, which means it has a maximum. All you have to do is figure out what the vertex is. Okay, so this is identical to the previous problem, even though it looks very different. Remember, to complete the square, we only need the first two terms, and therefore move the third one to the side. Then you need to factor the 1 over 28. So this will be s squared minus y minus, because since this value is positive, negative times negative will give you positive. And then this has to be 84s. How do I get 84? Notice that 84 divided by 28 gives you exactly 3. So that's how you check. Or you can do it right here, 1 over 28 times 84. You can check that this is 3. And then move over the 31. So the next step is you divide 84 over 2, which is 42, and then we square this value. 42 squared is equals to 1664. So you add this here, but remember, you have to be very careful that you are not adding this number exactly. You are adding this value times this one, or this value divided by this. So 64 divided by 28 is 63. So essentially you are adding minus 63. And how do you get a minus 63? Well, by adding 63. So we're going to add 63 here. So this is not the first time we do this. Check your notes from previous, from last week, or for week 5. And just check that this value times this one gives you this. Obviously, the reason why this one is positive is because this one is negative, and they cancel each other out to give you 0. Okay, you should check that. Then from here, you can rewrite this in standard form. So it will be s minus 42 y 42, because that's the value you got when you divide by 2. And then how much is 63 minus 31? That gives you 32. So therefore, this is the answer. So the vertex is 42, 32, which means that if the speed is 42 miles per hour, if you drive this speed, you will get the maximum mileage, and the mileage is going to be, so this will be the max. It's going to be 32 miles per hour, per gallon, per gallon. Now you can also draw a quick graph to this. So at 42, this is going to give you the maximum miles per gallon, which is going to be 32. If you go any faster, the miles per gallon is going to decrease. Also, you go slower than 42. So 42 is the speed that will give you the best mileage. And that's it.